Welcome to Chapter 9, Unit 10, Chapter 9. We are going to start off with a bit of algebra review of radicals. So if you don't remember, a radical is an expression with a radical or a root symbol. These undo exponents. For example, this symbol right there is a radical, and then a number they usually have a number underneath, or sometimes you can even have an expression underneath the square root symbol. This is a square root symbol. If it had like a 3 in front and it had an x, this is a different type of cube root. And you do not confuse these with divide. This is not divide. This is square rooting something or cube rooting something. The radicand is the number expression inside. So the radical is the little symbol outside. The radicand is what is inside. So here, the radicand is that 49. This is the radicand. It's whatever's underneath the square root. So of this, the radicand would be the x plus 1. This is the radicand. Next, a number with no factors besides itself in 1 is a prime number. So examples of prime numbers are 1, 2, 3, 5, 7, 11, 13, and so on. You can only divide it by 1 or itself. You cannot divide it by any other number. A composite number is a number that is not a prime. So any number that is not a prime. So 4, 6, 8, 9, 10, 12, 14. Every single even number aside from 2 is a composite number. Next, when we see the square roots, we have 3 outcomes. If the answer is simple, well, we call this a perfect square. For example, the square root of 49 is a perfect square because that is just 7 squared. So the square root of 49 is 7. Other examples, 25, that is just 5. Or 81, that is just 9. So those are called perfect squares because they just end up to being one simple number. However, if the answer is complex, the instructions tell us to round, we use a calculator. So for example, if you had the square root of 10, it's not a perfect square, but if they say round, we use a calculator, and it's about 3.2 once you put it into the calculator. However, if the answer is complex, the instructions tell us to simplify or find the exact answer. No decimals. So we will, when we do the exact answer, and we break it down to the tree. And we'll go over that in a little bit. So just a little repeat how to find a square root. First, we want to see if it is simple or complex. If it is simple, you have your answer. If it is complex, we make a prime, keyword prime factorization tree. And then from your tree, search for the pairs and the box. And we draw the root, and we put one of the numbers for each pair go on the outside, 1 go on the outside, and each of the numbers that with no pairs, keyword no, stays on the inside. If there is more than one number inside or outside, then we multiply them. So if you think about this, if there is a pair, we choose one of them, just one of the pair, and it goes on the outside of this radical. Here, this has no pair, and it stays underneath the radical. So let's try some of it out. First things first, we round to the nearest tenth, so the square root of 42. So we just punch that into the calculator, and we round it. This one should give me about 6.5. And then the next one, the square root of 75, that should give me about, punch it in calculator, 8.7. Square root of 21, that should give me about 4.6 from the calculator. Now, let's simplify the square root and leave as the exact, keyword simplify, and leave as an exact answer. So here's square root of 900. I'm going to first punch that in to see if it is a simple one. Oh, that square root of 900 is just 30. So that is my answer, just 30. Square root of 75. Oh, punch that in. I get a decimal. So I need to break this down using my tree. So I'm going to start with 75. I know 75 is 25 times 3. I'm going to circle my 3. Next, I'm going to break 25 down. 3 is a prime, so I'm circling that. 25 is 5 times 5. Oh, I'm going to circle these because these are the primes. Oh, I found a pair. I'm going to box that out. That's a 5, and then I'm left with a 3. So this is 5 root 3. Let's try this again. I have an root 18. Punch that in. That is a decimal, so I got to do a tree. 18. If I break this down, it is 2 times 9. Okay. Then if I break 2 is a prime number. 9 is not. 9 is 3 times 3. Circle those. Oh, I got 3's here, so I'm going to box that up. And I got a 3 root 2. So this is a 3 on the outside, and then a root 2 on the inside, because I didn't box up that 2. Let's try root 72. It is a decimal, so I'm going to break this up using my tree. 72, if I think about this, is I'm going to divide it by 2 because it's the easiest one to divide by. So 2 times 36. Okay, 2 is a prime number, not 36. 36, if I divide that by 2 again, this is 2 times 18. I'm going to circle the 2. I got 2 and 2. Okay, I'm going to box this up really quickly just to tell me this is a pair. 18, keep breaking that down. That is 2 times 9. I'm going to circle this 2. 9, if I break that down, that is 3 times 3. Okay, here's a pair of 3s. So I got a 2 and a 3, so I'm going to put those on the outside. 2 times 3, and I'm left with a 2 under the radical, because that's the only one left. That's circled. So 2 times 3 is 6. So this is 6 root 2. Okay, next one, number 5. We've got the square root of 13. 13 is a prime number. So the square root of 13 is the square root of 13. I cannot simplify square root of 13 any further. Number 6, we got 5 root 5. Okay, root 45. 45 is a decimal, so we can't square root it, but let's try to break it down. 45 is 5 times 9. 5 is a prime number. I'm going to circle that. 9 is 3 times 3. Oh, we got 2 pairs of 3, so I'm going to box in my 3. So this is 3 and 5. But don't forget my 5 on the outside. I'm going to write that times 3 root 5. 5 times 3 is 15. So that is 15 root 5 for number 6. Number 7, here, oh, I got the square root of 6 times the square root of 7. Those two, when you multiply like that, you can multiply them together. This is the same thing as saying 11 times 6, which is just the square root of 66. 6 does not have a perfect square, and 11 does not have a perfect square. So that is just my answer right there. Number 8, the square root of 10 squared. That's the same thing as saying the square root of 10 times the square root of 10, which is just 10 times 10, which is 100. And the square root of 100 is just 10 if you punch it into the calculator. Next one, we just did the square root of 10 times the square root of 10. That's 10. So this is actually 2. The square root of 10 times the square root of 10 is just 2 times 10, which just gives me 20. Number 10, here, 2 root 3 squared. So this is the same as saying 2 root 3 times 2 root 3. So then I'm going to move the numbers on the outside, 2 times 2, and root 3, I'm going to pair them together. Root 3 times 3. 2 times 2 is 4. Root 3 times root 3 is the same thing as root 9. And if I square root 9, that is 3. So this is the same thing as saying 4 times 3, which is 12.